In this lab, you're going to be standardizing a solution of sodium hydroxide. The reason we need to do this is because sodium hydroxide is hygroscopic. Let's talk about what that means. Let's suppose you wanted to make a 0.1 molar sodium hydroxide, and you want to make 100 milliliters of it. So you're going to take 0.100 liters, and then when you solve for this, you're going to need 0.010 moles of sodium hydroxide. So then you're going to take your molar mass to convert this, and you're going to add it up from the periodic table. It's going to weigh 40 grams. So you're going to take 1 mole, 40 grams, and you're going to take 0.01 times this, and you're going to need 0.4 grams of sodium hydroxide. So you're going to take your 0.4 grams of sodium hydroxide, you're going to dilute it into, let's say you use a volumetric flask, which you won't have to do in this case, but you put your 0.4 grams there, then you have 100 milliliters of solution, and you're going to think you made the perfect 0.1 molar, but you did not. And the reason is because this is hygroscopic, which means it absorbs water from the air. So this is going to absorb water very easily, especially from the air, anywhere else. And so this 0.4 grams that you measured of sodium hydroxide is really not 0.4. It's 0.3 something sodium hydroxide, and the rest is going to be water. So, excuse me, you can never make the perfect sodium hydroxide solution. So what you're going to need to do is you're going to need to standardize it. In order to do this, we're going to use an acid called KHP. Now, KHP stands for potassium hydrogen phthalate. Okay, so the K is really potassium. Phthalate, hydrogen is just hydrogen. And phthalate is really a formula of C8H4O4. It's not phosphorus. C8H4O4. So the whole formula is KHC8H4O4. This is a solid, so you could actually measure its mass very easily. And the nice thing about this is one H reacts with one OH to make water. They react in a 1-to-1 ratio. So that's the important thing you need to understand. So what you're going to do is you're going to need to figure out, well, how much of the potassium hydrogen phthalate am I going to need to react with this 0.01 moles. Okay, so if you need 0.01 moles of NaOH roughly, you're going to need about 0.010 moles of potassium hydrogen phthalate. And then what you need to do is figure out, well, how many grams is that? And then whatever that grams is, just move this over a little bit, whatever this grams is that you're going to figure out in your pre-lab, that's how much you need to measure of your KHP. And then once you find your KHP, you're going to take that and you're going to put it into your beaker, and you're going to dilute it with some water, and it's going to dissolve. And you know it's going to dissolve because we got a group 1 right here, so this rest of it is going to dissolve. And once you dissolve it, then you're going to put your NaOH that you made into the burette. Whoops. You're going to put that into the burette, and you're going to titrate. And you're going to figure out how much of the NaOH did you need to titrate the KHP. Right? And then to do that, you're going to know it reacts in a 1-to-1 ratio. So I'll write it out here for you briefly. You know that NaOH and KHP are going to react in a 1-to-1 ratio. So you don't even need to know the products. You just need to know this is a 1-to-1 ratio. So let's suppose that you know the grams of this, that you measured, that you actually calculated that you needed. Then you're going to change it into moles. And then when you're doing the NaOH, it's a solution, so you have molarity equals moles over liters. And then you're going to take this moles that you got, you're going to put it into here. You're going to read how much volume of NaOH you used in the burette from, there to there, let's say. That's the volume. So this is the volume of NaOH used. Okay, that number is going right there. And then you're going to solve for the molarity of the NaOH. So the interesting thing is you worked backwards. You said, I'm supposed to have 0.1 of this. I'm supposed to have 100 milliliters. How many moles is that? That moles is 0.01. Okay, so technically it should be around 0.01, but the point is you don't know how many moles this really is because it already absorbed some water. So we estimated this is 0.01. We estimated we need 0.01. We estimated how much KHP we needed, and that's what you figured out right here. So then once you estimated what you need, you actually measure it. Then you put it in here with some water. Then you actually titrate it with the NaOH. And then you knew you had this many grams, which you knew you had this many moles. And then at the equivalence point, when the indicator changes color, you're going to know that that's how many moles of NaOH you added. And then you know the volume of NaOH that you added. And then you're going to calculate the exact molarity of the NaOH. Okay, so you're going to have the exact molarity right over here that you calculated. And then what you're going to do is you're going to use the standardized base in lab number 7 to titrate a vinegar solution and an NaOH solution.